So we call this a separable differential equation because you can multiply dx to both sides. It's like this whole thing is dx. And then you can put an integral operator in front of it. And that's doing the same thing to both sides. We're taking the antiderivative of both sides. And look, there's no number written here, so you could put a 1. So what's the antiderivative of 1 with respect to y? That's y. Because if you take a derivative of this with respect to y, it'd turn back into 1. And same thing over here. We'll go term by term. The antiderivative cosine is sine of x, because the derivative of sine would make cosine. And then the antiderivative of this term here is a little bit tricky because if you were to take a derivative, the negative 2 would come down and multiply. So I'm going to make a negative 1/2 e to the negative 2x. Because the derivative of an exponential function is itself times the derivative of the innermost function and then times a natural log of the base. But natural log e is just 1. And then an antiderivative of this term is 2x squared. No, sorry, 2x to the third, because the 3 would come down and multiply, and then the power gets reduced by 1. And then we need this arbitrary constant c, because right now just this stuff, if you take a derivative with respect to x, it does turn into this. But look, if you add 1 to it, like let's say c equals 1, the derivative of this side also turns into this side. So when you take an antiderivative without limits of integration, like this, then you got to remember to put plus some constant c in your answer.